Synthesis. Cholesterol is synthesized from acetyl-CoA, which comes from fatty acid oxidation. So body requires 80 milligrams of cholesterol per day, out of which 500 milligrams is synthesized by the body and 300 milligrams is provided by the diet. And the site where cholesterol synthesis occurs is in the liver, intestine, skin, testes and ovaries. In the cell, cytosol and microsomal fraction of cells produce cholesterol. So the starting compound for cholesterol synthesis is acetyl-CoA. It occurs in 5 steps. So the first step in acetyl-CoA in cholesterol synthesis is synthesis of HMG-CoA. HMG-CoA synthesis is the first step. So how is then second step is mevalonate formation, and then third one is isoprenoid formation, and then squalene, and then cholesterol. So acetyl-CoA is converted to HMG-CoA by HMG synthase, and HMG-CoA is converted to mevalonate by HMG-CoA reductase. HMG-CoA reductase is the regulatory enzyme here. So what happens, this HMG-CoA is the regulatory enzyme, and it regulates the synthesis of cholesterol synthesis. So what happens is, one, it does so by feedback regulation. That is one way, and another regulation is by reversible covalent regulation. So in feedback regulation, what happens is, the excess cholesterol represses the HMG-CoA reductase. So by this is also called as feedback repression. And one more is reversible covalent regulation. This is hormonal regulation. So this HMG-CoA reductase is activated and it is in dephosphorylated form. It is inactive when it is phosphorylated form. So this insulin and thyroid, we know it acts when there is excess of glucose, so we can afford cholesterol synthesis. So so these two hormones dephosphorylate the HMG-CoA reductase, which stimulates thyroid hormone. Stimulates cholesterol synthesis. And these glucagon and glucocorticoids are the reverse of insulin. So it favors the phosphorylated form and form of HMG-CoA reductase, and inhibit the cholesterol synthesis. So what happens in starvation is, glucagon is increased. So HMG-CoA reductase is in the phosphorylated form, so it inhibits cholesterol synthesis. So what happens to this cholesterol? Mainly the catabolism. So cholesterol can be broken down to bile salts or bile acids. 80% of cholesterol in the liver is converted to bile salts or bile acids. It's the same. So conversion that is one. It is converted to bile salts and bile acids, and it's also converted to 4 classes of steroid hormones. We know the steroid hormones are mineralocorticoids, glucocorticoids, and the sex hormones, steroids. So conversion, that is one, and cholesterol is converted to 7-dehydroxycholesterol, which forms from synthesis of vitamin D. Sorry, for synthesis of vitamin D. So it is converted to 7-dehydroxycholesterol, which helps in synthesis of vitamin D. 7-dehydroxycholesterol is converted to cholecalciferol, which is vitamin D3. It is the active form. Then conversion to cholestanol and coprastanol, which is excreted in feces. It occurs. This conversion is by large intestine, by the intestinal bacterial flora. So this was cholesterol synthesis. Thank you.